Welcome, this is 2.3. We're talking about dividing polynomials. So last year when we did quadratics, we did lots of adding and subtracting and multiplying polynomials. This year we're going to add dividing into your repertoire. Okay, so our starter is kind of like dividing polynomials using a box. It's not my favorite. Some people really like it. I'm going to go over this at the end. So this video might be a little bit longer. If you like the long division, the way that I'm going to start with, you're welcome to just stick with that. If you're like, this is kind of confusing, I'm going to try this dividing polynomials using a box. You can go to this part, that part of the video, okay? So again, I'll come back to that in a minute. Okay, so basically what we're doing is we're going to divide kind of like what you did when we did long division with just numbers. So here's an example, right? If we're going to do long division, this is called the dividend, and this is the divisor. Okay, the divisor is what you're dividing things by. Okay, so sometimes people write it like this using this. I don't know what that's actually called. I should probably look that up. But we're dividing 184 by 4. Okay, so if you remember doing this in the past, great, it's going to be helpful. If not, maybe you'll learn something new. Okay, so when we're doing long division, we want to know, well, can 4 go into this first term, or this first number? And no, it can't. So we'd go to the next term, next number, and we'd say, well, what can 4 go into 18? And we could say, well, it can go in 4 times. Okay, so 4, so we multiply here, we get 16. And then that step, if you remember, we subtract. So I'm going to purposefully not put a negative sign because that's it. It gets us gets people confused when we get into the polynomial division. Okay, but just think we're subtracting every time. So 18 divides 16 would give us 2. Okay, and then we next bring down the extra number, the next number, and we can repeat that process. So how many times can 4 go into 24? And we'd say 6. And 4 times 6 will give us the 24. And then we would subtract and we would get a remainder of 0. Okay? So basically what we're saying is that when we go 184 divided by 4, we end up getting this is called the quotient. I should probably write these things down. So this is the quotient. This is the dividend, and this is the divisor, and this would be the remainder. Okay, so 184 divide 4, I'm just using a fraction to represent division, but you could use a division symbol like that, okay, is equal to 48 or 46, okay, with no remainder. Okay, and I won't write the remainder because there's not one, right? Okay, so that's long division. Let's do an example, very similar. Now we're going to divide it by 5. So that's our divisor, and we're going to divide 184 again. Okay, so how many times does 5 go into 18? I think 3, because that would give you 15. We'll subtract, we'll get 3, bring down the 4, and then 4 can go into 34, I think 6 times. So 6 times 5 is 30, and we'd have a remainder of 4. Okay, so again, we're basically saying 100, maybe I'll just write it over here. So 184 divided by 5 is equal to 36 plus 4 out of 5. Okay, so again, that's like our remainder. 5/4 would be the remainder. Okay, so we're going to be doing something very similar with polynomials. I know this might seem, this is basically what we're doing is these same types of problems. They might look a little different because maybe something might be a little off. So please make sure you at least go through this first page. Again, if you don't like the long division, the way that we're doing it here, you can always try the box later on, okay? So polynomial long division is the method for dividing polynomials. It's another by dividing, polynomial by another polynomial of a lower degree. It is very similar to dividing numbers. So let's kind of do the same thing. So again, this is our divisor. So that's what we write in front. Okay. And we want to divide the dividend, which is x squared plus 5x plus 6. Okay, and we're going to go through the same sort of process. So when we do these, the leading term is the thing that's going to like kind of drive our choices. So don't worry so much about this plus 2. It's going to just kind of tag along and we're going to see what we end up getting, okay? So we need to find how many times does x go into x squared, okay? And thinking about like variables, it's a little more complicated, but you could also think of as what do we have to multiply x by to give us x squared? So we'd have to multiply it by x, right? We want it to be the same as what's in the dividend, okay? So x times x will give us x squared, and then x times 2 will give us a positive 2x. Okay, so we did the multiplication part, just like we did up here. We took that 4 and multiplied it by 4 and gave us the 16. Okay, so now we're going to subtract. Again, I am not going to put a negative symbol. I'm just going to write sub for subtraction. You don't need to write that at all, but it just helps me remember that we're subtracting the terms above by what's below, okay? So if you did this right, this should always, like that first term should always cancel out. And then we'll do 5 subtract 2, because we're always subtracting, right? So 5 subtract 2 would be 3x. Okay, so that's great. Now, just like we did above, we brought down the next number or the next term, and we repeat. So here, what do we need to multiply x by to give us 3x? So we'd have to multiply it by plus, ooh, that was not great, plus 3. So when we multiply 3 times x, we're going to get 3x. And then when we do negative 3 times 2, we're going to get 6. And again, we're subtracting. So 3 subtract 3 is nothing, and 6 subtract 6 is nothing. So we end up getting no remainder. Okay? So if there is no remainder, then we know that our quotient would be x plus 3. And if there is no remainder, then x plus 3 is a factor. It goes in evenly, so it would be one of our factors. So we could rewrite this as x plus 3 and x plus 2. Okay? And we're going to do that more when we're trying to like simplify something in standard form to give us our zeros, our solutions, okay, our roots. All right, let's try another example. So as we go, we set it up the same way. We're going to divide our dividend by x plus 1. Now the thing about this is it takes a little bit of time to like go through it. We might learn, well, we will learn a little bit in our next lesson that might speed up this process a little bit, but I do want you to be able to do it both ways, okay? So again, we need to figure out what do we need to multiply x to give us x squared. So same sort of thing. So we multiply, we'll get x squared, and we multiply those together. So we get plus 1x. We'll subtract. So we'll get nothing in this term. And we'll get 5 subtract 1, so 4x. Bring down the 6, and repeat the process. So again, what do we need to multiply x to give us 4x? We have to multiply it by 4. And then we'll multiply to give us that 4x. And then we'll multiply to give us plus 4. And then subtract. Again, this cancels. And 6 subtract 4 would give us 2. So that is one of the common mistakes, is that, like, trying to keep that in mind, like the subtracting. We're always going to be subtracting. If you end up subtracting something that's already negative, then we'll end up subtracting a negative, which is a positive. So watch out for that, okay? So this one ends up having a remainder. Just like this example above, we had a remainder of 4. Here we have a remainder of 2. So how we're going to write this on our homework, sometimes it will ask you to do them separately, sometimes it will ask you to do them together. So we're always going to be writing down something that includes the quotient, which is this part, and the remainder. And we'll be writing that as a fraction. So for this one, it would be, the quotient would be x plus 4. And then we're going to add the remainder over the, I think it's the divisor. Okay, it's what's left over. So we'd have 2 over what we're dividing it by. So that would be x plus 1. Okay, so again, this is our quotient. This would be our remainder over our divisor. Just kind of like what we did up here. We said it was 36 plus 4/5. Okay, so it didn't go quite into 5. We still have something left behind. Okay, all right, let's do another example. Okay, oh yeah, I wrote that there so I wouldn't forget. So quotient plus remainder. Okay, and over divisor. Probably should write it like that. I think some of them it might just ask for the remainder, not the remainder over divisor, but I think most of the time it's like that, okay? All right, so important, fill in missing terms. So like this example, we have x squared minus 4. Here, when we do long division, we need to make sure we fill in any missing terms. So for this example, we're going to do x plus 2. We're going to want to see how many times that can go into, this isn't great, 3x to the third minus x squared, but we're missing the x term, so that would be plus 0x plus 11. Okay? So besides that, as long as you can make sure you don't miss any middle terms, then you should be good. Okay? So here again, what multiplies to 3x to the third? We'd need to multiply it by 3x squared. So this times this would give us 3x to the third, and now we'll multiply those together, and that would give us plus 6x squared. Subtract to give us, so this is negative 1, subtract 6, so negative 7x squared. Drop down the next term. And now we need to figure out, well, what do we need to multiply x by to give us negative 7x squared? So that would be negative 7x. Then we multiply this, and then multiply this. Okay, so negative 7x squared, and then negative 14x. Okay, then we're subtracting. So this will cancel, just like this one canceled. And we would end up getting 14x. because this one we're doing 0, subtract a negative 14, so that will become a positive 14. Drop down the next term, plus 11. And then we need to say, well, what do we have to multiply x by to give us 14x? So we'd have to multiply it by 14. And we'll multiply it by the next term, the 2, to give us 28. And again, we're subtracting. So 11 subtract 28. What is that? Negative 17. And that would be our remainder. Okay? Again, we want to write it in that same sort of form. We want the quotient, so 3x squared minus 7x plus 14 plus the remainder over the divisor. So negative 17 over x plus 2. Okay. I think this will be our last example. I'll show you a couple if you want to go over them on the next page, and then we'll go to the box in case you want that, okay? So again, we're dividing. So what's the, actually I don't think there's anything different here. Have we had ones with, no we haven't. So this is something that's a little different, is we have a coefficient in front of our x. So let's see if that makes any difference. So 2x minus 1. We want to see how many times that can go into 8x squared plus 10x minus 7. So same thing, we need to figure out what do you multiply 2x to give you 8x squared. So that would be 4x. So multiply to give us 8x squared. We multiply will give us negative 4x. Again, we're subtracting. So 8 subtract 8 will give us 0, and then 10 subtract a negative 4 will give us 14x. Bring down the next number. What do you have to multiply 2 by to give us 14 would be 7. So 14x, and then we multiply, and that would give us negative 7. And then we subtract, and we'll end up getting 0. So again, if there is no remainder, that means we only have the quotient. So 2x, no, sorry, the 4x plus 7, again, that's your quotient. Okay. If that's there's no remainder, that means that 2x minus 1 is a factor of our original equation. Okay? So for this example, since these are both factors, we could, we're going to end up in the future breaking that into the two factors, and then from there we could come up with those key properties of polynomials or graph, things like that. Okay? All right, so the next page, I went over all of these and I didn't find anything that I thought was quite different than what we've already covered. Maybe some of them there's more terms, or they're all cubics, a degree of 3. One thing that you should be aware of is that when we're dividing a degree of 3 by a degree of 1, again, it's kind of like when you divide variables that we subtract their exponents. So we end up getting, our answer should be a degree of 2. So just keep that in mind. I think that's going to be more important when we get into our next lesson, but be aware of that. So if you're welcome to pause and try a couple more examples. I know it takes a little bit of time, but the more you practice, the better you're going to get, okay? All right, so I'm going to pause at that point, but and then I'm going to go and we're going to talk about using a box. If you feel like you were okay doing the long division, I would just stop now and stick with that. If you want to use the box, great. So I'm going to go over that now. So in the past, when we've multiplied polynomials, we've used a box. So I'm going to go through one of those really quick. I think there's 2 examples, but we're just going to do one of them. And we would multiply to give us our terms. So 3x to the third, 9x squared, 12x, 2x squared, 6x, and 8. And then we would combine like terms, right? So we'd end up getting 3x to the third. We can combine those two to give us 11x squared. Combine those two to give us 18x, and then our constant's 8. Okay, so remember doing that. There's another example here if you want to give it a try. But if you want to divide using a box, we're basically going the opposite direction. So if we want to divide this by this, then we're going to take our, again, this is called the divisor. We're going to put our divisor on the side, and we're going to kind of work our way around until we can find our quotient. So that's what this is going to give us, right? All right, so now let's go through this process. So we always put in our first term, and then we're going to kind of fill in what we do know. It's almost like Sudoku, where if you know some of the stuff, you should be able to find some other stuff, okay? So we should be able to figure out what this is, because these two should multiply to x squared. So this should be x squared, right? Now we know this, we should be able to multiply these two together to give us this spot. So this would give us what? 1x squared. Okay? So this and this term should multiply to give us negative 4x squared. So that means that this box would have to be negative 5x squared. Does that kind of make sense? It's kind of like when we did these, we were able to combine like terms. Okay, so those diagonals will always add up to give us the term that matches the same degree. So that ends up giving us that negative 4. And now we repeat the process. What times x? These two should multiply to give us negative 5x squared. So it would have to be negative 5x, right? Multiply those together. Oops, I missed it. Those multiplied will give us negative 5x squared. Now we should be able to figure out this box, because 1 times negative 5x gives us negative 5x. Okay, so now we've got an x term. It should combine, these two should combine to give us negative x. Okay, so what would that have to be? 4x. So 4 minus 5 should give us that negative 1x. And then, again, we're just keeping that same process. What times x, what times x would give us 4x? So it would have to be 4. And then we can multiply this by this to give us our next box would be 4. And as you notice here, that those match. These match, okay? That means that there's no remainder, okay? If the constant matches that, then there is no remainder, and we're done, okay? So then we could write our answer. We could say x squared minus 5x plus 4 is our quotient, and that also means that x plus 1 is a factor. I know it already said that, over here, but, okay? Let's do one more example, if this is helping you, okay? All right, so again, the divisor will go here, x minus 3. Our first term would go right here. And we need to figure out what do we have to multiply to give us that x to the third, so that'd have to be x squared. Now we can multiply those two to give us negative 3x squared, but it needs to be negative 4x squared. So this would have to be negative 1x squared. See, those combine to give us that. And then again, we're just repeating. Repeat, repeat, repeat. So this would have to be negative 1x. So this and this multiply correctly to give you this term. And then we'll multiply this by this to give us 3x. But it shouldn't be 3x, it should be negative 1x. So we'll need to subtract 4x. Okay, so that gives us that. And then we'll repeat. So this, wait, where are we at? This times this should give us negative 4x. So this has to be negative 4. And then we'll multiply these two to give us a positive 12. So here, 12 isn't 4. So we would need to subtract 8. And now we are done. This is going to be our remainder. So our answer, our divisor, our quotient, our quotient would be x squared minus 1x minus 4 with a remainder of negative 8 over x minus 3. Okay, so again, it's our quotient, our remainder, and our divisor. Okay, so one thing, I didn't really talk about this previously, so you get a little help, but using that same dividend, that same original equation up here in the top, find f of 3. So if we just plug in 3 for every x, okay, and you use your calculator, you end up getting negative 8. So we're going to maybe talk more about that in our next lesson. Okay, but what do you notice that how this is related to something that we just talked about? This is our remainder. Okay, so if you ever need to know the remainder and you don't want to have to divide everything out, okay, you just have to take the 0. So here this is the 0 for x minus 3. Okay, you can just take the 0 into the equation, and that ends up giving us the remainder. Okay, we'll talk again, like I said, we'll talk more about that next time, because some people probably didn't get this far in the video. Okay, all right, well, let me know if you have any questions. I will see you later.